I have opened one of the architectural drawing. Here we have ground floor layout plan. We have a steel building which is almost 31 meter by 18.5 meter in length and width. Here you can see the opening to the building. Here we have the staircase area, and you have some other amenities over here: toilet space, chemical store, lab room, and other facilities. At this top corner, you have this waiting lobby area, and this is the space for the office space. And here we have these locations of the columns. Okay, so this is the basic ground floor layout. Now, as a structural engineer, what is important to us is the column layout. So let's understand the next thing, the steel column layout plan. Here you can see they have marked the steel columns from A, B, C to G, and 1, 2, 3, and 4. So these are the locations of the columns. Here we have the staircase area, and at certain places here it's written VB. VB stands for vertical bracings. So we have certain bracings. Okay, so this was regarding the column layout. The next drawing here in detail we have regarding the beam layout. Okay, so most of the people are requesting regarding the recording. So I would like to inform that it is already being recorded and the recording will be shared with all of you by the organizers. Okay, so I won't give permission to record it locally. Okay, so this is regarding the beam layout. Here you can see the red color beams. These are primary beams, which are connection between column to column. And then you have these blue color beams, which are secondary beams, which are connected between the primary beams. And this is staircase area, so of course you won't have any beam over here. The next thing what is important to us as a structural engineer is the elevation of the building. Here you can see we have a rough elevation. We have a 600 plinth level, and above plinth the ground floor starts. We have floor to floor height of 3 meter, and we have almost 5 floors up to roof level, and then we have this headroom which is of 2.4 meters in height. And this is the location of bracings, the vertical bracings. So this is the basic information which we need from the architectural drawing. Now the next step is to model this thing in Staad Pro software. So next, now I am going to open the Staad Pro software. Here you can see we have the Staad Pro connected version 2. Let's just open it. Okay, so this is the layout of Staad Pro. When you open it, this is the front page. And if you want to open a new model, I can just press new over here. Or if you want to open your existing model, you have a lot of history over here. Your last opened model, you can just click on it to open it. Now we are going to start with a fresh model. So let's click on new. So let's give the name to our building G+5 steel building webinar. Okay, so you can save it anywhere. The location, type of structure is analytical. When you see units over here, you have two options, English or metric. We should always choose metric if we want to have units like meters and kilonewton. And if you want to model a structure in feet, inches, pounds, then you should go with English. So generally I use the metric system. So click on metric and just say create. So this is the page which opens. I will roughly explain you some of the buttons which we have, or some of the options which we have. At the top corner we have many ribbons, all kind of buttons which will help you in modeling your structure. One by one we will be using them. This is the window where you can model your structure. At the left side you have many types of analytical modeling, physical modeling, builder, piping, bridge. For various kind of structures you have a separate kind of modeling system, but we are going to go with the analytical modeling. On the right hand side you have the option for your nodes and for option for your beams. But a simpler version, what we are going to do is, we have this CAD file which we received. I am going to prepare one more CAD file where I will be marking all my columns, beams and secondary beams, and I will save this file as a DXF file, and I will directly import this DXF file into my Staad Pro. So I don't have to start from zero. So I'll just start with a new drawing. On L. Starting from zero. Okay. So the length of my building is 31.08 meters. So I want all the units in meters. So I'm going to draw this in meters. 31.08. And my width is 18.32. 18.32. Oh, okay. So just let's check it again. Here you can see 31080 and 18320, column to column, column to column. So this is in millimeters and we want in meters. So I have 31.08 and 18.32. Next, I have my central columns at a distance of 7385, 7385, and my last is 3550. Okay, so let's mark offset of 7.385. Yeah. And in other direction, I have 5.18 meter, 5180. So I will just say offset of 5.18. So now you can see these are all the locations of my primary beams, and the intersection between these primary beams are all the locations of my columns. Now I also want to draw the secondary beams. My secondary beams are at a distance of 4.77, 1.477. Okay, and the last one are at 1.775. Okay, 1.477. So I'll just go in the drawing, offset 1.477. Let's draw all the secondary beams. And the last one is 1.775. So here we have drawn all the primary beams, all the secondary beams, and all the column location. So this is my drawing. I will just save this drawing as a DXF file so that I can import it. I will just give it the name G plus phi web the file. This is my location. I will just say save it. And I have to close it from, otherwise I cannot import it. Okay, so I'll also save that as an internet. Okay. So now let's go back to our Staad Pro. Now I will be importing this CAD file, the DXF file. So I need to go in file. Here I have the option of import and export. I just click over it. Here I have the option of DXF file. When I click over it, I need to choose the location. And right now I had created this file G+5 webinar. Okay, so I will just say open. When I say open, I get this option. I need to provide it direction. So in my figure, you can see in my Staad, Y direction is the upward direction. So I will just choose Y up and I'll say I need to choose the units and I will choose the units as kilonewton meter. So meter and kilonewton. Just say OK. Okay, so now you can see this thing has been already generated over here, but we have one problem with this. You can see you have this complete members length to length. I need to break these members at all the intersections. So the easier method is I will just choose all the members, just say Control and A. Then I have the option at the top. It's called Beam Tools. Click on the Beam Tools. And here I have the option of intersect beams. Click on the intersect beams and you get some tolerance over here. Just say OK. Now you see I have created this 142 new beams. So all my beams are broken now and it is easier for me to model them. The next step is I want to copy this for all my floors. So first I will copy it for one floor and my floor distance is okay. I'll show you. Just choose all the beams. In geometry, you have the option over here called as translation repeat. Click on it. This is the tool used for copying it. We want to copy this in Y direction. So choose Y. Right now, I want to go with one step and spacing is 3.3 meters. I will just say OK. So the same thing has been copied. Now I want to draw my columns. So here I have the option in geometry. Again, I have this option add beams. I'll click on add beams. I'm drawing these columns. 1, 2, 3, 4. I know after 4 secondary beams, again, I have a column. 1, 2, 3, 4. Yeah. So these are my 4 beams. Now I just need to copy them at all the locations. So I will just choose them. Go in the beam tools, copy, paste, reference point. I will choose this point, the bottom point as a reference point, and I'll just say OK. And I just need to choose the point where I want to copy it and just press enter. You can see we have copied all the column locations. Now I want to draw the bracings. Again, I'll click on add beam. I will draw these bracings. Okay, so the location of bracing. How we decide the location of bracing? This is one of the important question. In my drawing right now, the location of bracings were directly given by the architect, but in certain cases, as a structural engineer, we need to define the location of bracings. So this is my structure, this is my building, and I want to have the X, let's say in plane YZ. In YZ plane, I want to have my main frames. So this will be the direction of my main frames, and When I want to connect two frames, I will use this bracing location, and generally these bracing locations are provided at the initial and at the end, and then somewhere in the middle, and then you have to model it and go for trial and error to find the perfect location. But generally it is provided at the ends, and then if it is a long beam, somewhere in between. And the purpose of these bracings is to take horizontal forces which come in case of seismic forces and wind loads. Okay, so I have these two. I will just choose them. I want to break them again. So again, I'll go in the beam tool, intersect beam. Okay. So now I have broken them into 4 points, 4 beams. One more thing I'm going to do over here is, see, when I click on this beam, you see at the center, I'm getting the blue part of my beam, and near the column, I'm getting the green part. The green part of the beam is the point from where the beam is starting, and the blue part is the point where the beam is ending. So this shows me the start and end of my beam. So here my end of the beam is near the center. For the bottom one, again the blue one is in the center, but for the top one, the blue one is near the column. The top one, blue one is near the column. I want to change this. I want all my beams to end at one point. The reason I'll tell you later. Okay, so I've chosen both these points. I want to change the starting and ending of this. So just I need to go in beam tools. Oh no, I'll go in the utilities. In utilities, again, I have option of beam tool, and in beam tool, I have the option of beam indices. Just click on beam indices and I can switch my beam. So once I switch, now you can see all my beams, all my bracings are meeting at one point, and that's the end. So this is easier for me in the future. You will understand why. I just choose my bracing. I want to copy it. Beam tool, copy, paste, choose a reference point at the bottom. Okay, and I choose this point. Yes, so I have my beam at the other end also. Okay, so again I will choose this. Now let's see where are the various locations of my bracings. I have my bracings at this point and after two bays and at the last bay. Okay, so just I'll go in my Staad, copy it, paste it.
ये अदरक से क्या बनाता है अदरक का लीटर
Okay,
देखी नहीं है मैं प्रोटीन से चाय नहीं पी है नहीं
I
तो
need
हम रेगुलर
to
सुबह शाम कॉफी तो बनाते हैं चाय पीते हैं
mute the participants. Okay, reference point. Yeah, this is the reference point. Okay, I will copy it over here after two bays and in the last bay. Generally, we provide this in the first and last bay and then somewhere in between. Now I want to have 4 floors of this. So I'll go in view. I will see in the front view. I will choose all my bracings. One more thing, near the staircase, I want to delete at the bottom. First of all, in the bottom, I want to delete all these members. The reason behind this is up till 0.6 meter, I have my plinth level. And from there, I am going to start my floors. So I don't need beams in the bottom. So these are my columns and my beams going to start from the top. And this is the staircase level. So I don't want to have any secondary beam in between my staircase. So I just delete it. Yeah, this is the space for my staircase. So now I just copy all the members, and in geometry, I have the option of translation repeat. Now I want to repeat this 4 times, and the spacing is 3.3 and the direction is y. In y direction, number of step is 4 and spacing is 3.3. If you have separate spacing, you can change it over here. But in my case, it is same, so I won't change. I have the last floor of 2.4 meter, but that is just a headroom. So I don't need to copy the whole structure. Okay, so you can see I have copied it 4 times. Now what we need, this area, in this area we have our headroom. So I just choose that member, right click on it, new view, click on new view, say OK. Now when I see, only that part is visible to me and it is easier for me to do any changes. So I'll just choose the members of my headroom. I want to copy this, copy, paste at a distance of y 2.4 meter. Just say OK. Again add beam. Now I want to draw the columns. And this is the secondary beam at the rooftop. Let's draw it. Yeah, it's done. Now I want to see my whole structure again. So go in view, display whole structure. Now you can see your whole structure. Let's go to our drawing again to see if we are missing anything. Okay, so we have this building. We have drawn all our bracings, all our columns, all our beams. The headroom is also ready. Up till 0.6 meter, my plinth level, it would be sub-footing, substructure, and substructure, of course, it will be of concrete. And from here, my steel structure will start. So I have not done this in my structure. Okay, so I think we have done all the things. Structure is ready now. Now we need to assign properties. Before assigning properties, we will group them in various categories. So here you have option of utilities. In utilities, you have option of groups. Click on groups. Let's give the group name. First is column. Type is beam. It is a beam type of structure. Say OK. Next is my primary beam in X direction. Again a type of beam. OK. I have my primary beam in Z direction, the main frame beam. I will just OK. Next I have my secondary beams. I'll just say S beams. Again they are beam. Next I have my bracing. Again a type of beam. Okay. One thing what we are missing is the slab. We have drawn all the beams and columns, but we also have slab. To apply the loading, we need to also model the slab. So we will close this for now. We want to model the slab now. Go in view. In the front view, I will choose the first floor. Just right click, say new view, say OK. Now I am seeing only my first floor and it is easier for me to model my slab. Just go in geometry. I want to model it as a plate. Click on plate. Click the 4 corners of my slab. So column to column. This is one slab. Again, column to column. My other slab and my third slab. Generally, this cursor which you see, this is a beam cursor. And when I want to choose my plate, it is not possible. I need to change the cursor. So I need to go in select. Here I have option for node cursor, beam cursor, plate cursor, solid cursor. Now I have a plate. So I'll choose plate cursor. Now I can choose my plates. I have pressed control button and chosen all the 3 plates. So it is easier for me to copy them. Go in the plate tool, say copy, paste. I want to choose a reference point. This is the point. That's good. Okay. Click on the point. 1, 2, 3. 4, 5. Okay, so I've copied all the plates. Again, I'll go in select plate cursor. Now I want to copy, I want to delete this plate because I don't want to have slab in my staircase level. So when I select this, all my slabs are ready except my staircase level. Yeah, that is nice. Go in view. I want to display my whole structure. Now I want to copy these slabs at all the levels. So I will just go in the plate tool, copy, paste, or better it could be I will just go in geometry and translation repeat. Then I can just give it that you want to copy it 4 times and the distance is 3.3 meters. I will just say OK. Now all it's been copied. If I want to see, I will just choose all the beams, all the plates have been chosen. Now I want to have my top plate at the top corner that is not drawn. So I'll go in view, front view. I will choose this member, right click, new view, say OK. And I just want to draw one plate over here. So go in geometry, add plate and choose these 4 points. Okay, so it's ready. Let's have a view, display whole structure. Now all my plates are also ready. Now again, I can go in utilities group. I want to add my 5th group as slab. I will choose it as a plate because slab is not a beam, it's a plate. Say OK. Now you can see I have created these 6 type of my members, but right now they are not assigned. I have not assigned them. I have just given them the label. So to assign them, I will go on select. First, I want to assign my columns. Go in the select parallel to Y. So all my members parallel to Y are selected and I want to label them as columns. So I'll just say associate to selected geometry, associate. Next is my beams in X direction. So I will just go parallel to X. But the issue now is the primary and secondary beams have been selected. So I'll just right click, say new view, OK. And I will view this thing from the top. I know my primary beams are only at the ends, these ends, and this is also my primary beam, and I have one primary beam in the center. And 4 beams are these are secondary beams. So I have chosen all the primary beams. If you want to see at all level primary beams have been selected. Associate to selected geometry, associate. Now beams in Z direction. Before that, I will just assign the secondary beams. Just view the top again. These 4 and these next 4 and this last one. These are my secondary beams. If I see in 3D, you can see all the beams have been marked. I will just say associate to selected geometry. Yes. Now I will display my complete structure. Yes. Now I want to select beams parallel to Z. Yeah, all the beams parallel to Z have been chosen and I will associate them to the selected geometry, beams parallel to Z. Next is bracing. One of the simple method to assign bracing. I've chosen beams parallel to Z. I'll choose beams parallel to X. I will also choose beams parallel to Z and parallel to Y. So all the parallel beams have been chosen. I will just say inverse. Once I say inverse, other than that, all my structure is selected and these all are my bracing. Now it is easier to associate geometry. Yeah, done. Now I want to choose my slab. I want to choose my plates. I will just go in plate and select all the plate. Yeah, that's it. Simple. Associate to selected geometry. Yes. So I have created these 6 groups. Let's check it again. Column, highlight it, all the columns. beams in X, beams in X, okay, beams in Z, beams in Z, my secondary beams, all the secondary beams, my bracings, all my bracings, and my slabs. So I have created this group. Now I want to assign properties. To assign properties, first is geometry. We have created this geometry. Next tab is the properties. Now I want to assign all my property. What I will do, I have the option over here, section database. I will click on this.
Welcome you all in ISO certified live training program ETABS, RCDC and Excel that makes you a professional structural engineer. In this training program you will learn everything about ETABS and RCDC from basic to advanced, real life project of medium rise structure from architecture plan to final design sheet, real life project of high rise structure with all advanced topics, design of structural elements using advanced Excel sheets. Have a look over the features of this training. Daily live classes conducted by expert for 1.5 hours. Recording of every session with lifetime access. Can interact with expert anytime, 24/7. Exposure to real practice. ISO certification of training completion. It's 5-star rated training program. Till now more than 1,000 participants have benefited from this training program. Now you are the next. Hello everyone, welcome you all in a new ISO certified live training program, design of substructure using CSI Safe, Excel and manual. In this training program you will learn all about the concept of substructure design, commands in CSI Safe software for the substructure design, validation of CSI Safe result with your manual and advanced Excel sheets. This training program will cover 4 real life projects. In the first and second we will cover all the types of isolated foundation in CSI Safe software. In the third real life project we will cover the raft foundation, and in the fourth real life project there will be the coverage of pile and pile cap design of basement wall, and at the end of this training program you will learn how to prepare the final design sheet for the site execution. Have a look over the features of this training. Daily live classes conducted by expert. Recording of every session. Can interact with expert anytime. Exposure to real practice. ISO certification of training. It's 5-star rated training program. Till now more than 1,000 participants have benefited from this training program. Now you are the next.
Yes, okay. Now the section database is open. In this you have all kind of sections which are available in various market. You can see we have the American standard, the Australian, the Brazilian, the Canadian, and all other countries. I want to go with the Indian standard. I choose Indian. S shape, I want to have my shape as, I will go down, ISMB 600. I want ISMB 600 for my column. I will say add. Next, I want ISMB 500 for my primary beams. ISMB 500, say add. I want ISMB 400 for my beams in the other direction. ISMB 400. I want ISMB 250. ISMB 250 for my secondary beam. I've added it. And I want channel section. This was for I section. Now if I want channel section, I have option over here, channel. Click on channel, and I want to have a channel of 250 for my bracing. Add. Okay, so once all of the thing is chosen, just say close. What I did, I have chosen some of the members. I will run the model. I will see if it is safe or no. If it is safe, I will see what is the utilization, what is the efficiency. If the utilization is very less, I will reduce the member. If it is more, it's fine. And if it is failing, then I will increase the section. So these all depends on trial and error. Generally my columns will be the heavier one, then my primary beam, the main frame, will be a little lighter, then the supporting primary beams will be much lighter, secondary beams will be lighter one, then I have my bracings, and for slab I need to give thickness. So I have option over here for thickness. Click on thickness. I have 100 mm of slab, so I will just choose 0.1, and the material is concrete. Say add. Okay, so I have modeled my slab. I have given the thickness to it. Now I want to assign them. So to assign them, I just need to click select group. I will choose all my columns. Okay, just
Sir, how to decide the preliminary size of the columns and the beam?
yeah, I will be sharing with you. So you can share the questions in the comment box. Later we will answer them. I will also answer the question.
Okay, sir. Thank you.
Okay, so the basic how you should decide the size of the columns. It will first of all, if it will depend on trial and error method, and secondly, you should understand your columns will be the heavier ones, and then you have your primary beams, and then you have the beams connecting your two frames, and then the secondary beams, the bracings. So it depends on trial and error, and after some experience, you understand what should be the difference between these various members. I choose my column. All my columns are selected. Assign to selected beams. Say assign. Yes. Now I want to assign beams in X direction. ISMB 500. All my beams in X direction. Assign. Yes. ISMB 400. I will choose beams in Z direction. Say assign. Yes. Now I want to choose my secondary beams. All my secondary beams are selected. Say assign. Yes. Now I want to choose my bracings. All my bracings are selected. ISMC 250. Assign to selected beam. Assign. Yes. And lastly, slab. I want to give it a thickness of 100 mm. Choose slabs. Assign to selected plates. Assign. Yes. So now you can see we have assigned all these members. So if we want to have a view, in view you have option of 3D rendering. Just click on it. You can see all the members have been assigned. I will just zoom and show you. You can see this is my columns. These are my primary beams. These are the bracings, and these are my small secondary beams. And the purple or this pink color, the purple color is the plates. But I have one issue here. These are my bracings, and this is my column. So the other direction of my bracing. So this is my frame, main frame. But you can see the column, the orientation of column is in minor axis for my main frame, which I don't want. I want my main frame to be in this direction because the bracings are in other direction. So generally where we have bracings, we do not have main frame also in that direction. So I want to rotate all my columns by 90 degrees so that I get it as my main frame. So for that, I will just choose all my columns. Here we have option of beta angle. Click on beta angle, create beta angle. I will create a 90-degree angle. Say OK. I will unselect this, highlight assigned geometry. So when I choose beta 90, this doesn't get unselected. Now I will say assign to selected beam. Assign. Yes. Now all my columns have been rotated by 90 degree. So if I want to check it again, I will just click the 3D rendering. Now when I zoom, you can see this is my main frame. These are my main frames, and all these are in major axis. And then my two frames are separated by this distance, and they are supported by this bracing. Yeah, so this is what I wanted. So it's correct. So I'll just close it. Now we have all the members assigned.
Sir, why
Next
we
thing,
are all column rotated by 90 degrees, sir? Some column are rigid. We have to change, na?
yeah, generally it depends we do not have all the orientation of all the columns in one direction only, so that when we have in RCC building we do that case, so that when we have earthquake in other directions, so that our structure is stable from both the directions. But in my case, I have bracings in one direction, and in other direction I want to have my main frame. So that is the reason I am having all my frames in one orientation and the bracing in the other orientation. I can also change the angles. Certain things I can keep it in 90-degree and certain things I can keep it in 0-degree. That is also one option. But in this case, I have chosen this because I have bracing support from one side and I have my main frame support for the other side.
Okay.
Material, you can see steel has been assigned to all my members and concrete has been assigned to all my slabs. So geometry is done, properties are assigned, material is automatically assigned. Next thing is specification. In specification, what I want to add specification for my beams. I will just click on beams. I'll first add it and I'll explain you the reason. I want to give certain releases. So release location start. I want to release the moment. Say add. Again, I'll click on beam. This time I want to give release in both start and end direction. So start, add, and beam, end direction, add. I'll tell you the reason behind this. Firstly, I have given release for all the start of my member and I want to assign this to all my bracings. So when I select group, if I choose all my bracings, I want to have a connection between my bracings and my column as a shear connection. So all my axial force from my bracings will be transferred to my column. So for that reason, I want to give it a release so that moment is not transferred from my bracing to my columns, because the connection which I am going to give is a pin connection and that won't transfer any moment practically. So in the model also I have to prepare such a thing. That's why we are giving this release, and I'm giving release in start of all my bracings. So that is the reason initially I changed the orientation of these two columns also. So it is easier for me that I can say start of my members are all connected to my column and I want to release all the start. So this is simpler in case of modeling. That's why we changed the orientation earlier. Now also this secondary beam. For the
Sir,
secondary beam also I want to have a shear connection between my primary beam and secondary beam so that it doesn't take moment. So that's why next two steps I am going to assign for my secondary beams.
sir, could you please tell us where we have to use shear connection or moment connection?
Where you want to use your shear connection and where you want to use your moment connection, it depends.
To define.
If we are giving a bracing, and bracings are generally axial members, they transfer all the axial force. If you want to connect your bracing to your column, in that area you should always give a shear connection because you don't want the bracing to transfer the moment. If you don't want your member to transfer any moment to the other member, you should give a shear connection. And if you want it to also transfer the moment, in that case we give a moment connection. Like between our column and our primary beam, we are not giving any release, we are giving it as a rigid connection. So my frame, it will be a proper frame which will also transfer my moment. That is the reason I am not giving any release for my column and primary beam, and that will be the area where I will give a moment connection. But for my secondary beam and my primary beam, the connection, this I want to have a shear connection because I don't want my secondary beams to take moment and transfer it to my primary beam, because then it will be like a torsion in my frames. For my main frame, if I have this moment coming from secondary beam, then it will create a torsion and the connection will be very complex. So to have a proper connection, a shear connection, a simple connection, we are giving secondary beams in start and end releases. That's why we are giving shear connection at these points. In practically,
Sir,
right now what I have done, for all my frames and my primary beams, for my columns and primary beams, I have given a moment connection. But in practical, we don't give all these moment connection, because again, to design a moment connection, it's a complex task. What we do, we find certain areas where we define our primary beam to be the main frame, which will take moment, and we release some of the moments from other primary beams also. But right now we do not have that time to simplify our connection, so we are giving all our main beams as moment connections and secondary beams as shear connections. And of course bracing will always be shear because they are axial members.
सर ये साइट पे कैसे एग्जीक्यूट होगा सर? ये तो आप स्टैट में तो आप बता रहे हो कि ऐसे ऐसे होगा, लेकिन जो ड्राइंग आएगी साइट पर वो कैसे आइडेंटिफाई करेगा कि यहाँ पे ये शेयर
उसमें
कनेक्शन
भी
है?
होता है, हम जब कनेक्शन डिजाइन करते हैं, हम प्रॉपरली कनेक्शन डिजाइन करने के टाइम पे हम सोचते हैं वेदर दिस कनेक्शन इज अ मोमेंट कनेक्शन और शेयर कनेक्शन. सो अगर हमारा आई सेक्शन है, वी हैव दिस आई सेक्शन, इफ यू वांट टू हैव अ शेयर कनेक्शन, we should have the connection between our web and the member only. We should not fix our flanges. So when we are having a connection between the secondary beam and the primary beam, the web of the secondary beam is connected to the web of the primary beam with the help of clit angle,
यस सर.
and the flanges are free to rotate. So if any moment comes, slightly the flange will rotate and it won't transfer the moment to my primary beam. So we give the drawings accordingly. It's not like in Staad we are modeling a shear connection and practically on site we are just giving them a random connection. For connections also we have proper drawings where we define this is my moment connection which will take particular kind of moment and particular kind of shear, and this is my shear connection which won't take any moment and it will only take shear force, that to certain extent. And based on that we decide the number of bolts required, the size of bolts required. So the design of connections is also one of the important part in structural analysis. Right now we are focusing on this modeling. Design of connection is the next step.
Okay.
So the basic understanding is, if you want to give a moment connection, like we have a frame connection, our columns, our primary beams and other column, if we want to have connection between them, we need to connect clit angle with our web and our column, and we need to also have angle connecting our flanges, top and bottom flange, to our column, so that it is a rigid thing and it is not easily rotatable. And if you want to rotate it, then the moment will be transferred to my column. So when rotation of my flanges are not allowed, then that is a moment connection. And when my flanges are free and only my web is connected, that is a shear connection. Now the next thing is support. Now we want to give support. Again, here we have the question whether we should give a fixed support or we should give a simply supported thing. Again, this depends on our type of structure and on our type of substructure. Because if we give a fixed connection, then that fixed connection will take all kind of moments, biaxial moments, and all kind of shear force and axial force, and these all forces should be resisted by our footing and by our step column. And in that case, my footing and my step column will become heavier because I am giving a fixed connection. In other case, if I give a simply supported connection, my footing will be simple because it should only take the axial force, and it should not take any moment. But in that case, my whole structure will be slightly heavier because my supports are simply support connection. That is why the reason my column would become slightly heavier, because it is also taking the moment, and it is the moment is not transferred to my connections. So if we want to have a heavier superstructure and a lighter substructure, then we go for pin connection. If we want to have a heavier substructure and a lighter superstructure, then we go for a fixed connection. Again, in that case, the design of substructure becomes much complicated. So this also depends on trial and error. Also, it depends on type of our soil we have. If we have if it's not possible to have like a raft foundation and we are only capable of giving an isolated footing, then it's easier to have a pin connection. Okay, so in this case, we are going to give a pin connection because we want to have isolated footing and we don't want our footings to be much heavier. So I'll go in view, see the front view. I will choose all my bottom supports, assign to selected support. Here I have already chosen the pin support. Say assign, yes. So all my bottom supports are pin supports now.
सर इसमें प्राइमरी बीम्स इन एक्स डायरेक्शन पिन कनेक्शन है ना सर?
Primary
Because they are
beams,
connected to the because they are connected to the web, so they are
can you repeat the
pin
question?
connection, sir. Primary beams.
Huh,
Sir,
primary
the
beams
primary beams in x direction, sir. They are
in X direction, yes. Huh.
they are shear connections, है ना sir?
No, primary beams in X direction, they are my moment connection. मैंने
Because
उनको
they are
release
connected
नहीं
to
दिया. They are
नहीं
connected to other
तो
column.
वेब में कनेक्ट हो रहा है ना सर? वेब में कनेक्ट हो रहा है ना?
हाँ बट
Client
हाँ बट जो मेरा प्राइमरी बीम है उसका फ्लैंज अगर मैंने क्लिट एंगल से सपोर्ट किया दोनों साइड से इवन इन एक्स डायरेक्शन, ये मेरा जो बीम है प्राइमरी बीम, फॉर दिस बीम दिस इज हैविंग कनेक्शन विथ माय कॉलम. इसको भी अगर मैं उसका
yes sir,
जो
yes sir.
फ्लैंज है वो मैं होल्ड करता हूँ, देन इट विल बिकम लाइक अ मोमेंट कनेक्शन. बट ये जो मेरे सेकेंडरी बीम से जो मेरे प्राइमरी बीम को कनेक्टेड है, फॉर देम आई हैव गिवन रिलीजेस.
जनरली फिक्स कनेक्शन फ्लैंज को देता है, वेब को नहीं देता है बोल के सुना है सर.
नो, इट्स नॉट दैट केस. जनरली वो वैसे करते हैं, हम फ्लैंज
वेब
को
में
फिक्स
फिक्स
कनेक्शन
कनेक्शन नहीं
देते हैं,
देता
बट वेब
है. दैट
में
इज वेरी थिन.
वेरी थिन है. बट दूसरे उसके दूसरे भी टाइप्स है, हम उसका एक डायगोनल मेंबर देकर उसको सपोर्ट देकर कर सकते हैं. इट्स नॉट ऑलवेज कि हम उसके फ्लैंज को होल्ड करेंगे. एक छोटा सा हम डायगोनल मेंबर देकर हमारे प्राइमरी बीम और वेब ऑफ कॉलम को सपोर्ट देके उसको भी हम एज अ मोमेंट कनेक्शन डिजाइन कर सकते हैं. जनरली ऑफ कोर्स इट्स नॉट प्रिफर्ड बिकॉज व्हाट पीपल डू इज कि एक डायरेक्शन में हम उसको मोमेंट, ये मेरा मेन फ्रेम है, मेन फ्रेम को मैंने मोमेंट कनेक्शन दिया
यस सर.
और दूसरे जो डायरेक्शंस में उसको मैं सारे शेयर कनेक्शन देता हूँ. दैट इज ऑल्सो वन केस. बट अदर केस कैन ऑल्सो बी कि अगर उसको भी हमें मोमेंट कनेक्शन देना है, देन देर आर अदर मेथड्स ऑल्सो बाय
तो
विच
वो
वी
जगह पे सर वो जगह प्लस प्लस कॉलम भी दे सकता है ना सर? बिल्टअप कॉलम्स दोनों साइड
कैन.
फ्लैंजेस आना चाहिए सर.
यस यस, वैसे भी रहता है. Okay, so geometry is done, properties we have assigned, material also is done, specification we have given, supports also we have decided. Now the main important part is loading. What are the various loadings which we want to apply on our structure? So let's go back to our slide where I will be showing you some of the modeling in Staad Pro. Yes, it's done. First load. In Staad Pro, if we want to apply earthquake load, we should always apply that initially. That is the condition of Staad Pro. While modeling, when we want to apply earthquake load, we should apply that first. Then it's otherwise we get some error in this. So let's understand what is earthquake load. Earthquake load, there can be 6 cases of earthquake load. Earthquake load can come from any direction, and we have plus and minus for particular direction. So plus x, plus z, minus z. Generally, we have these 4 directions, but also it could be plus y minus y in the vertical direction. So there are these 6 cases of earthquake as I have roughly shown in this figure. Then how we apply this earthquake load? As per the code IS 1893 2016, what we do is we calculate this base shear. The base shear formula is AH into W, and the seismic horizontal coefficient AH, as per the code we have this formula Z by 2 SA by G R by I, where Z is the zone, SA by G depends on type of our soil, R is the response spectrum, I is the importance of our structure. So these values we can find from the code, and the W, that is the seismic weight of the building, it depends on weight of our building. So all these parameters, we do not have to calculate all these things now manually. We just have to enter what is the zone of our structure, what are the type of structure, importance of our structure, what is the soil type, structure type and all. When we assign these parameters, the other calculation, Staad Pro does by itself. It calculates the base shear and applies this base shear to the supports. So we don't have to worry regarding this. So we just have to assign the parameters. The next thing, how many load cases we have in case of earthquake. So most of the people might not be aware of this. As per our clause 6.3.4.1 in IS code, if we have zone greater than 3, generally this is the thing, this is what is stated in the code. When we are considering load in x direction, earthquake load, we should also consider 30% of load in y and z direction also, because it's not like the load will only be available in x direction and y and z won't have any load. So the code says that when we are considering load in x direction, also consider 30% in y and z, and this is applicable in both positive and negative sign. Similarly for y, you should consider load in x and z 30%, and z you should consider 30% in x and y. So if we consider this
Sir, our
thing,
structure is orthogonal, sir.
yes,
Sir, our structure is orthogonal, then this 0.3 will not come here, sir. If it is non-orthogonal, then only this 0.3 factor will come.
yeah, also if we have the zone
Because
of,
our factor is orthogonal.
okay, let's see what does that mean. We will answer that question. If we have this structure where we want to consider all this 30% also, in that case, let's understand how many type of load cases we have. We have this load in x direction where we have the factor of 1. In that case, for y, we could have plus 0.3 plus in z also plus 0.3. Y is plus 0.3, z is minus 0.3. Next is y minus 0.3, z is plus 0.3, and both are minus. So when we have plus 1 x, we have 4 combinations with y and z. So we have these 4 cases. If we have this minus x, again we have more 4 cases, so 8 cases. And the same thing is for y and z. So 8 cases in x, 8 case in y, and 8 case in z. So total we have these 24 cases. Next is our dead load. In dead load, first thing what we consider is, of course, the self weight of our structure. And we generally use the factor of 1.1. This additional 0.1 factor is not the factor of safety what we consider. This is due to the load of the connection. We have this shear connection, moment connections, and the connection between the bracings and the member. For that, we consider 10% of weight. That is why we use this factor 1.1. Next, we have the weight of this wall. In my case, I have this height of the wall as 3 meter, width is 125 mm, block density is 6.7, plaster we have of 20 mm on both sides, mortar density I have considered as 20. So we calculate this UDL of the weight of wall, height into width into density plus height into thickness of plaster into density into 2, because we have plaster on both sides, we get this weight of the wall, UDL,
Sir,
which is to be applied on the wall.
sir, is this factor is fixed or we can change as per the
Yeah,
structure?
this will of course change as per the structural. So in certain cases, if we have very heavy connections, then we can take 1.15 as the factor. And also if we understand what could be the weight of the connections, then this could also go up to 1.2 and 1.3 depending on the weight of our connection. So this additional factor is the factor of the connection between the two members, because Staad is only analyzing the members. It is not considering the connection. So to also consider the weight of the connection, we are considering this factor, and it will depend on structure to structure and as per the experience of the engineer.
Is there any criteria, sir, how to decide the which factor we have to select as
No,
per the structure?
no, this is as per our type of connection. If we are having very complex and all connections are moment connection, then we go for higher factor. Sometimes we accurately calculate the weight of the connections from the fabrication drawings, and then we see what is the factor and give that factor. Or generally, it's if we have a simple structure, just go with 1.1. Next is this weight of the parapet wall. Of course, we have a height of 1.2 meter, lesser than the total height, and we have calculated this UDL accordingly. The last one is the weight of slab. I have my 100 thickness of slab. Concrete density I have considered 24. Based on that, I have this pressure.
The concrete is 25 kilonewton per meter cube, है ना, sir?
Yeah, 24, 25. Of course, it could vary. Next is my live load. Live load on slab. This we have taken as per IS 875 part 2. This is my assembly building, and in that, if we consider the office room, I have the factor of 3 kilonewton per meter square as per the code. So I have taken this value 3 kilonewton per meter square. So that was regarding dead load and live load. Next, we want to consider the wind load. So of course, the calculation of wind load is very lengthy, and as per IS 875 part 3, I have taken some of the screenshots of the code and I have pasted over here so that it's easier to understand.
Welcome you all in ISO certified live training program ETABS, RCDC and Excel that makes you a professional structural engineer. In this training program you will learn everything about ETABS and RCDC from basic to advanced, real life project of medium rise structure from architecture plan to final design sheet, real life project of high rise structure with all advanced topics, design of structural elements using advanced Excel sheets. Have a look over the features of this training. Daily live classes conducted by expert for 1.5 hours. Recording of every session with lifetime access. Can interact with expert anytime 24/7. Exposure to real practice. ISO certification of training completion. It's 5-star rated training program. Till now more than 1,000 participants have benefited from this training program. Now you are the next. Hello everyone, welcome you all in a new ISO certified live training program, design of substructure using CSI Safe, Excel and manual. In this training program, you will learn all about the concept of substructure design, commands in CSI Safe software for the substructure design, validation of CSI Safe result with your manual and advanced Excel sheets. This training program will cover 4 real life projects. In the first and second, we will cover all the types of isolated foundation in CSI Safe software. In the third real life project, we will cover the raft foundation. And in the fourth real life project, there will be the coverage of pile and pile cap design, design of basement wall, and at the end of this training program, we will learn how to prepare the final design sheet for the site execution. Have a look over the features of this training. Daily live classes conducted by expert. Recording of every session. Can interact with expert anytime. Exposure to real practice. ISO certification of training. It's 5-star rated training program. Till now more than 1,000 participants have benefited from this training program. Now you are the next.
First, we are starting with calculate wind speed. We need to understand what is the wind speed. VB into K1, K2, K3, K4. VB is the basic wind speed based on the location. Then we have these 4 factors based on risk coefficient, terrain factor, topography factor, and the importance factor for cyclic region. So K1, this depends on my type of structure and the type and what is my basic wind speed. Based on this, I can get the value of K1. Next is terrain factor K2. This depends on height of my structure and what are the nearby areas of my structure. So again, that is classified into 4 categories, category 1, 2, 3 and 4. Next, I have my topography factor. This depends on the location of my structure, whether it is located in a hill, cliff or a ridge. Based on this, we calculate this value. Or if it is if my structure is just located in on a plain surface, plain area, then I have the value of 1. Otherwise, based on the slope of my area, this could vary from 1 to 1.36. Next is my factor for importance due to cyclic region. If my structure is located in a cyclone prone area, then based on type of my structure, I have some factors. If my structure is not located in this area, I just take the factor as 1. And based on these 4 K1, K2, K3, K4 and the basic wind speed VB, we get this value of Vz. Based on this, we calculate the pressure PZ, 0.6 Vz square. Again, we have some factors Kd, Ka, Kc. These are wind direction factors, area averaging factors, and some combination factor. But this PD should not be less than 0.7 times of my PZ. So 0.7 PZ is the minimum which we can reduce our PZ to get the design wind speed. Now the value of KD is based on the type of the shape of my structure. If my shape of my structure is triangular, square, rectangular, as in our case, then we have the factor of 0.9. If I have a circular building, then I have a factor of 1. Next is the area averaging factor. This depends on my tributary area, means the area where my wind is going to be applied. If that area is less than 10 meters per square on one side, then the factor is 1. And based on this area, if it is between 10 to 25, then we have 0.9.
How to find this area averaging that?
We have our main frame. So if we calculate the length of my main frame and the width of my main frame, that area between my columns and beams, that area is the tributary area.
That is
And
one frame.
yeah,
44 is like 16 meter square. So this is like between the two.
like my one between two columns, the spacing between two columns and my height of my structure, that is one single tributary area.
So the whole structure or
No, the single frame.
we have taken the two column and between the different floor.
No,
So we
for
have to take
not the whole structure, but my single frame where if I am applying force, then it is being resisted by my column, by my first floor beam, and my again the other column. That area is the tributary area for this particular, not the whole structure. Otherwise, it will always be more than 100 meter square,
Yeah.
and the factor will be always pointed. But not that for a single frame.
Okay.
We have this next combination factor, and generally this combination factor is taken as 0.9. Next we have the wind load for on individual member force. This F, we want to calculate the force on our member. It depends on CPE minus CPI, the external and internal pressure coefficient, and the area where my force is being applied, and the pressure we have right now calculated. Area will depend on my spacing of the columns, and these CPE and CPI, right now we are going to see how we can calculate that. First is internal pressure coefficient. This will depend on the opening of my, if I have one side of the wall, depending on the doors and windows, there is certain opening in them. If that opening is less than 5% of my total wall area, then I use the factor of 0.2. If the opening is between 5 to 20%, then the factor is increased to 0.5. And for the opening of greater than 20%, we have the factor of 0.7. That is for internal pressure coefficient. Next, for external pressure coefficient, this will depend on this table, and depending on the ratio between my height and width, ratio of my length and width, based on the building plan ratio and building height ratio, I have these values, and they also have separate values for 0 degree of wind and 90 degree of wind. Okay, so these are some of the values. All of these calculation is automatically done in the Excel sheet, which I will be showing you later. You just have to choose your type of structure and some of the parameters related to wind locations, and all these values will automatically be calculated. So I'll be sharing you that Excel tool. Now let's understand how many type of wind cases we have. We have this building. This is our A side of wall. Next we have B side of wall, C and D. Of course, this is the building which we are doing right now. If we have wind force coming from one direction, A direction, of course it will go out from the other three direction. This is how this wind load is calculated in Staad. We just have to give it certain parameters. Again, if wind is coming from B, it will go out from the other three directions and the wind is at the other side. If wind is coming from C, it will again go out from the other three directions and we have this other combination. And for D, again, we have the other combination. So these are the four combinations of wind load. But again, we have plus value of CPI and also the minus value of CPI. So again, we have four combination for plus and four combination of for minus. So we have 8 wind load combinations. 0 degree and 90 degree, again left to right, right to left. So in this case, for wind loads, we have these 8 wind load combinations. Okay, so we understood regarding earthquake load, dead load, live load, and wind loads. Let's understand based on these combinations, how many we have the total load combinations. As per IS 800 2007 table number 4, we have these factors for strength criteria, combination factors for strength criteria, and combination factors for serviceable criterias. Here you can see we have our dead load, live load, wind load slash earthquake load. This is important for us. So based on this table, we have in total 194 combinations. Like one combination for dead and live, 8 combinations for wind, and 24 combinations for earthquakes. And again, based on separate factors, we have 129 factors for strength criteria and 65 other factors for serviceable criteria. Of course, if we are not considering that 30%, then this number will be reduced to 4 or 6. And if we are considering that 30% in Y and Z, then this is the maximum what we can get. Okay, so this we will be applying now. I will go back to my model and I will show you the Excel. Okay, so we have this Excel and the sheets marked in green color are important for us. We can directly copy values from them and paste in our Staad software. So, and here in this page, geometric parameters, the cells marked in yellow color, you can change these values, and remaining values you don't have to change because those are automatically generated. So in my case, length is 31.08, width is 18.32, height is 18.9, spacing between my frame is 5.18, seismic load, I have these 6 categories: dead load of wall, parapet, slab, live load. As we have seen in the presentation, these are the values. Now for wind load, you can see here you need to choose the basic wind speed. As in my case, my basic wind speed is 39. Then class of structure, whether it is a general building or a temporary structure, or if you change this value, this value will change, and accordingly the design wind pressure will change. Farm building, so in my case it's a general building. Category, I have a closely spaced obstruction. If I do not have any obstruction, then the values will vary. So this is the case. Topography, if I have a hill or cliff, again the values will be different. Type of structure, if I have a general building or an emergency building, and what is my frame type, if it is rectangular or a circular thing. So based on this, the values will change. Opening, if my opening is less than 5%, then CPI values will be different. Like in my case, it is
Hello,
0.2 less
sir.
than
Sorry to
5.
interrupt. I have some small doubts, sir.
Yes.
Sir, regarding seismic, it is a lateral load. Like we have to consider
Hmm.
it for X or Z. Why we are considering along for a vertical side also, sir?
Yeah, generally seismic is a lateral force and we consider X and Z only. But in certain cases, we also have to consider Y, because uh, there could be a slightly vertical force also, but majorly the force is the horizontal seismic force. That is where we consider these 4 cases. But in certain cases, we also consider the Y direction based on the structure and based on the client requirement or based on certain parameters. So this is a rare thing what we consider. In general case, this is the 4 things what we consider. But as I wanted to give you a whole approach, I just showed you all the 6 directions what we could have. So
Okay, thank you,
once
sir.
when you choose your values from here, you get this green cells over here which shows various heights, and based on these heights what is your wind pressure. This thing you need to add in your wind load definition in Staad Pro, which we will be showing you next. This second table is regarding wind load. As I told you, you have these 8 wind load cases, and these values are calculated h by w, l by w, the ratios between your height, width, and length. Based on this length, you have these external pressure coefficient factors. Because if you look in your IS code, you have this big table, and you have to every time calculate manually these factors and calculate the result. But we have made a simple version where you just have to mention your length, width, and height, and these values will automatically come over here. And these values will also be added and subtracted from the CPI values, and you will get your CPE minus CPI coefficient from here directly, which you need to add in your Staad Pro model. Again, you don't have to add this one by one. We have this Staad Pro editor. These from this Excel tool in Staad Pro editor, these values will automatically come over here, and you just have to copy this green part and paste in your Staad Pro editor, where you will get all this wind load applied. Similarly, for earthquake load, you have these certain factors, but what you need to do is just copy this dark green part and paste it in your editor. Same for combinations, because we have this 194 combinations, and it's not possible to add each and everything manually. So it's common for all type of structures. So there is this general code which is available, and you just have to copy this in your Staad Pro editor. Okay, so we will be doing this. Let's go to the model. First, let's start with definition. We will first define the seismic definition. Click on seismic definition, say add, and we will choose our code IS 1893 2016, and you have the option over here, click on generate. When you click on generate, you can choose your city or your zone over here. Okay, and I have chosen the zone 3. Then a response reduction factor. My building is a steel building with ordinary moment resisting frame. Importance of my building, it's a general building, so all other buildings. Type of soil, I have medium soil. And type of structure, it is my steel moment resisting frame building, steel MRF building. Okay, and damping ratio is 5%. You can just keep as it is. You just have to say generate, and these factors will change, and you can say add. It's added over here. Regarding the wall weight, self weight, and all this, we will directly do in Staad Pro editor, so I can just say close. Next, I have my, yeah, it's done. Now wind definition is done. Remaining part we will do in the Staad Pro editor. Now I want to define my wind load also, wind definition. Click on wind definition, say add. Let's type wind load and say add. That's it. Click on wind load. Now we need to give here the intensity and the height of my structure. So go to my model. From here you can just copy these things. Say Control C, copy, and just paste it over here. You have all your wind intensity and your various height of your structure. Say add. Exposure factor, these all we will directly do in the editor. Say close. So this is the advantage of the Excel. You just have to enter your building sizes and your loads. So this value will automatically you can get, so you don't have to manually keep on calculating every time.
Will you share this Excel sheet?
Yes, it will be shared with you.
Thanks.
So one more issue is so how the software will determine this zero level? How that means from the 0 point is already defined.
Yeah, the 0 point is already defined in our model because this is the starting point, that is 0.0, and the top point is something 18.5 meters. When we are
They should, yeah, because
modeling
I
the
show
structure,
yes, I show when this specific definitions the foundation's depth and all there is one parameter. So I think we didn't define this one. This
yeah, that could be some advanced steps which we need to define when we want to precisely calculate for seismic definition. But for just an overview, we have not defined that thing. You are telling about when we click on generate,
yeah.
you are speaking about this time period, foundation depth and all.
Yeah,
So
yeah.
right now by default whatever Staad is considering, we are taking that because we have not calculated the foundation depth and all, and we have not calculated the periods. So right now whatever Staad is roughly take, we are going with that. So for
Because
us,
I'm
it's a
asking this
simpler
question
approach.
is because sometimes when we do this stat model, usually we refer the elevation like what is given in the architectural elevations based on this beam sea level. So in that case, when we define this wind load intensity, so we have to give based on this actual locations. No, if it is 101 or 103, whatever, based on the mean sea level, we have to feed that. No, so not from zero.
You are speaking regarding wind load or the
Yeah,
this
I mean, yeah, that's okay, fine. So I'm asking about this wind load intensity.
No, regarding the wind load intensity, this depends on my terrain
Yeah,
category, which I've already chosen.
yeah, that's correct. Because the height is measured from existing ground here. That means 0,
Yes,
10, 15.
yes.
But in our case, if we model like this, existing 0 is equal to, let's say, 100 MSL, mean sea level.
Mhm.
So in that case,
Okay.
we have to define the height as 100, 110, 115 like that. Oh,
Okay, yeah, I am question. You're saying when we are mentioning height over here, this height should not be from the ground level, but it should be from the mean sea level.
yes. In that case, my Y should be, it's a global point, no?
Yeah, I understood. But yeah, as per what we are considering, I will just check this question and we will answer it.
Okay, thank you.
Okay, yeah, I understood your question. Okay, so this was regarding the wind definition and the seismic definition. Now the definition is done. Now we will actually apply them. So next option we have over here is the load case detail.
सर वो विंड
Okay,
लोड में भी
load
तो
case.
आप वहाँ पे IS 875 पार्ट थर्ड होगा ना?
हाँ, part 3. I said 75 part 3.
मैं सर एज पर कुछ और लिखा हुआ था, प्लीज चेक कर लीजिए.
Yeah, wind load का जब मैं क्लिक कर रहा हूँ यहाँ पर, if you want to calculate as per a American code, then you have to go from here. But if you have any general codes like Indian code, you just have to mention your intensity and height over here. This is separate tab. If you want to calculate by ASC, then click over here. But in
Okay.
our case, it's a custom thing. We are not fitting in any of these things, so it's a custom thing. So we are giving intensity and height by ourselves.
Okay, got it.
सर हाइट स्लैब लेवल पे देने का है ना सर? हाइट स्लैब लेवल पे देने का है ना सर?
Slab level पे? I'm not getting the question. Slab height वैसे ही
जो
दिया है अभी.
विंडो wind load का
Okay, so wind height is defined, and you have this load case. Now we have to define the other load cases. First of all, we should always define the earthquake load. So EQ X plus, here I will choose seismic, say add. Now earthquake EQ X minus, I will just add the 6 load cases EQ Z plus, EQ Z minus, EQ Y plus, EQ Y minus. So of course the load in Y is very rare case, but just to have a complete understanding, we are considering it right now. Then we have our dead load and live load. Next is wind load. I will just mention one, wind load 1. We have total 8 wind load cases, but remaining we will directly add in the Staad Pro editor. And also regarding the earthquake, we can directly modify these loads in Staad Pro editor. Now we will apply dead load. So just click on dead load, say add. First is the self weight factor. We have this factor as 1.1. Add. Next we have the member load. Let's see the Excel. First member load we have 4.913. So choose 4 minus 4.913. In global y direction, say add. Next is 1.965 minus 1.965. Add. And the last one is 2.4 kilonewton per meter square. That is the plate load. Minus 2.4. It will be again in global y direction. Say add. So we have added some dead load. Let's add this live load.
Sir, above slab
Live
load.
load value
Sir. Hello,
minus
sir.
3. Yes, and this will also be in the local y direction. Yes.
Hello, sir.
Yes, you can ask. We can
Sir,
add this.
above slab load on a finish load added.
Above slab load
on a finish load, like
yeah, the floor finish load. Yeah, you are speaking about the floor finish load. Right now we have just considered that into our slab load. We have not added that separately. Okay, that could be the thing what you should add.
Okay, sir.
Now let's we have only defined these loads.
I have one question.
Yes.
Why we are adding in dead load pressure GY minus 2.4, as we have already modeled the plates with self weight minus 1.
Yes. Okay, let's in properties we have already modeled this plate and we have given the definition of concrete and yeah, the thickness is added. Yes, so this could be a thing that if we are giving this of 2.4 again, yeah, this is actually
This should not be there.
Repeating things. So this generally should not be there. Okay, so we will just delete that load case as yeah, I was adding it twice, so that should not be the case because Staad Pro is considering it by itself also, so we should not add again that manually.
Yeah, if we are not modeling the plate, then it will be fine. But if we are
Yes.
modeling the plate with self weight minus 1.1, it will be taken care of.
Okay, so now we have defined these forces, loads. Now we want to apply them. So just click on the first one, self weight, assign to view. You can say assign. Yes. Next is the weight of our walls. For that we will choose, go in, select just groups. We will choose all our primary beams because in all our primary beams we have these walls. I will just right click, new view. Okay. And we do not have wall at the top Okay. Okay, something changed over here, and let me check how I can bring it back. Yes. Okay, go in view. See from the front view. We do not have wall in our top floor on our terrace. So I will just choose these three and click on plus, dead load, assign to selected beams, assign, yes. And this we want to apply on the parapet wall. So I will choose this, right click, new view, okay. And in this also I only want to apply it on my edges. So choose it, assign to selected beams, assign, yes. Okay, I will just need to mute. Next, for live load we need to apply this value for all our plates.
सर फ्लोर लोड में फ्लोर
select-
फिनिश का लोड अप्लाई करने का है ना सर?
हाँ, अप्लाई करने का है, but right now we have not considered it. It could be considered.
हम भी तो कंसीडर करेगा, लेकिन फ्लोर फिनिश तो अलग से देना पड़ेगा ना सर?
Yes, yes. In dead load floor finish हम दे सकते थे, but right now we have not considered it. It should be considered. Okay, so assign to selected plates, assign, yes. So live load is assigned, floor finish also it should be assigned, but right now we are neglecting it. Dead load is assigned. This is the things which we assigned it manually. Remaining for earthquake and wind load, and the load combination, let's see how we can do this using.
टेरेस पर आपने लाइव लोड दे दिया पूरा का पूरा, वहाँ पे रूफ लाइव लोड चाहिए ना, क्योंकि अर्थक्वेक में हम उसको पकड़ते नहीं।
ओके, सो टेरेस पे लाइव लोड नहीं देना है।
हाँ, तो अर्थक्वेक में पकड़ते नहीं ना उसको,
तो
लाइव लोड को।
अर्थक्वेक के लिए हम डिफाइन करेंगे, अभी अर्थक्वेक नहीं डिफाइन किया हमने,
पूरा
जनरल लाइव लोड डिफाइन किया है।
हाँ, पूरा लाइव लोड आपने डिफाइन किया।
हाँ, तो लाइव लोड जब मैं
वो
डिफाइन
तो सिस्मिक वेट का है ना वो।
हाँ, वो तो पूरा ही डिफाइन करूंगा। व्हेन आई एम डिफाइनिंग ओनली लाइव लोड, आई विल डिफाइन कंप्लीटली what you are saying. It's regarding live load consideration for seismic, which we consider 25% if it is less than 3 kN per meter square. That is the next step. I will be showing you that.
But at the terrace you are not considering live load. Zero.
तो एक्सेसिबल है तो 1.5, नॉन एक्सेसिबल तो 0.75 किलोमीटर पर स्क्वायर मीटर देना पड़ेगा ना सर?
क्या बोला आपने, फिर से बताइए।
वो ऊपर में एक्सेस प्रोवाइड किया तो 1.5 किलोमीटर पर स्क्वायर मीटर लाइव लोड देना पड़ेगा ना सर?
एक्सेस लोड
हाँ, ऊपर में
टेरेस पे,
टेरेस में सर। एक्सेस प्रोवाइड किया तो 1.5, नॉन एक्सेस है तो 0.75 देना पड़ेगा।
ओके, सो राइट नाउ हमने शायद डायरेक्टली 3 दिया है। ओके, वी विल सी दैट। member load, element load. So I am just minimizing some of the things which we don't need now. Element load, member releases, supports, yeah. So from this part I will just, when you type 2 stars and whatever you want to add a comment, you can just add it over here. So right now this is seismic definition. Okay, seismic definition. Here we have defined the code. Here we have defined the zone and these factors. Other things we have to define yet. Next, here this is wind, wind definition. Here we have defined type of wind and intensities and the heights. Okay. Next thing here we have seismic loads. So 1 to 6, I will show you how you can edit these values. Next is dead load. Dead load we have self weight, member load. Yes, and then we have
Hello, sir.
yes, live load. In live
The
load,
dead
yeah,
load is assigned 2 times. Please check, sir.
member load. Yeah, it's ये member load हमने assign किया wall के लिए and this is for the parapet. Live load में this is for the plates. And then we have this wind load. Of course, there are certain comments regarding live load that it should be less on the terrace, but right now for simplification, I have just given the same for all. Also, the floor finish is not added in dead load. That should also be added. Yes, and I will show you how you can now modify this to get complete values. First, we will start with seismic definition. For seismic definition, the next thing what you need to add, you need to consider the weight. When you go in this Excel, here you have the option for earthquake load Staad editor. Just go in this tab. This you see you have already defined. These member loads you need to copy it from dead load. And I'll show you how you can copy, and this is always same. So I am just choosing that. I'm copying it. Open my Staad editor. And I will just choose these 6 values and I will just say paste. So after every load case, I've assigned that. I will say perform analysis change. So this is what it should be done for all the 6 cases.
Can you please explain me why we use this change command after the analysis? What's the reason?
Yeah, this is some kind of Staad thing, because whenever we apply Staad, whenever we want to apply seismic load in Staad Pro, it is always suggested that, of course, it's a mandatory thing that we should apply it first, because when later we apply earthquake load, we get some error. And again, after applying this earthquake load, we always have to add this command of perform analysis and change. Otherwise, you get certain kind of errors in this. So that is the reason it's a Staad Pro general command which we have to add. Okay, so here we have defined. Other thing what we need to define over here is the weight. So we go in this dead load. I'm copying all the dead load from self weight to member load. Right now we are not added this element load like plate, the floor finish. So that also should be done. But right now we are just skipping it. And here you see, I have just copied I will just write a comment so it's easier to understand. I will say dead load considered for seismic. ओके
सर लोड्स को माइनस डायरेक्शन नहीं रहता है ना सर?
हाँ, वो अभी कर रहे हैं हम. स्टेप बाय स्टेप वी विल गो एंड वो सब करेंगे. Now you can see here we have written self weight and we don't need to give minus sign. Also the direction is not important. So just write self weight and 1.1. So मैंने direction और sign delete कर दिया. Same for member load. We don't write load, we write here weight. Just delete the word load and replace it with weight. And also you have to delete the minus sign and also the direction. Same, delete the minus sign and delete the direction.
Sir, could you
This we
please
did.
Could you please
So
tell us why we are doing this thing? Like direction and sign have deleted
yeah, this is a Staad Pro thing.
syntax.
Yeah, it's like Staad Pro syntax. So when it is considering dead load, when it is considering weight of building, it doesn't require sign, because that is the reason you don't have to apply sign, and it doesn't require the direction because this is the weight of the building. So that is the reason you do not have to give direction and sign. So that's like syntax of Staad Pro. Next is live load. So copy the load of live load, and when the live load is less than 3 kilonewton per meter square, as in our case, for seismic loading we only consider 25% of it. So I'll just write 25% considered for seismic. Here I have pasted this value. Again, I have to delete the sign and direction and also the value. It was 3. I have to multiply 3 with 25% and I will get 0.75. This is 25. So as per the code, we have, if we have earthquake load, if we have the live load of less than 3 or 3, we have to consider 25% of it in the weight of the building. So I have written over here. So this completes our seismic definition. Okay, so I'll just make it. This is our seismic definition. Next, we have the live load. For live load, this is fine. Wind definition is done. Seismic definition is done. Dead load is done. Live load is done. Now wind load. For wind load, we have just given this title. But what is good about this sheet is you just have to go in wind load Staad editor and choose this dark green part. In this, all your 8 wind load combinations have been written, and their value is already taken from this, which changes when you change these values. So it's a dynamic sheet, and you can change as per your project, and you just have to paste it over here. You have 9, 10, 11, 12, 13, 14, 15, 16. 16 wind loads cases. You have just written it over here. Next, you have load combination and envelope. For that also, it's a general thing. You just have to go in this sheet, dead load, live load, wind load, and choose all your dark green part, all the combinations. Just copy it because this will be same for all your projects, and paste it. So this we have done the definition for loads. I will now.
Sir, here is showing 1012229 envelope. This thing will change, na? If something have, if you change from syntax.
Yes.
We have to consider.
In this case, in your Excel, what you need to change, you are telling if the number of load cases you want to change. Like if you are not considering this earthquake in Y direction, then this will become 5 and 6.
So they will
You just these yellow parts are the change. Green will automatically be generated. So yeah, it's partially editable. So you should understand how this Excel is done. So you can use it for all, or otherwise you have to use the same thing always. So of course, there are certain changes which you should understand. Like if you are considering only 4 cases, you don't want 8 cases. Means you are not considering wind from left to right and right to right separately. If you are having a symmetric building, then again you have 4 wind cases, and then again you have to do certain changes in this sheet. So you have to understand this before you want to use it altogether.
One more question, why we are not using this reference load method? So this method is convenient as compared to reference loads, or what's the reason behind this?
This is, I think, yes, we have all kind of loads which are possible. That's why I'm going with this approach. Yeah, there could be many other different approach also.
But so whoever is the first time doing this thing, so how can I grasp all that thing?
Of course, it is not possible for any of you to understand this if you are going for the first time. But this we are just trying to show you how in certain industries how certain things are done. So it's just an overview. Of course, you won't be able to understand everything in detail, and most of the topics what we are doing, we are just touching it and we are not going in much detail, because a 3-hour session cannot be
Yes,
where
I
you
agree
can
with
learn
you, sir.
everything.
So please tell us where I have to go for detail, like earthquake, how to
Yeah,
make it for
that
that.
we will discuss later in detail how you can understand all these topics like earthquake, wind loads, and dead load, live loads, these combinations.
Okay.
Hello,
Okay.
sir.
And if we
Hello.
want to check, yes,
Sir, dead load case is defined 2 times. You had just renamed dead load, but case is live load.
in Staad Pro editor,
Yes, sir. Yes. Can you please go in Staad editor and please
yes.
correct it?
If I go
Just
in
check live load
command
case.
file,
Load type live load.
yes, I'm checking it. Uh, yeah, here you can see first I have defined seismic definition. In seismic definition, oh wait, this, yeah, seismic definition, dead load considered for seismic definition, 25% live load considered for seismic definition. Then I have defined wind. Then here we have seismic loads, and here we have dead load. Here we have live load, and here we have this wind load. I think you were confusing it. This is dead load what we are applied.
No, what he's telling is correct, I think.
Sir.
Because
Roll
what
number
he's telling is the live load is the name, but the load
Yes, sir.
type should be changed to live. So what he's
Yes,
telling.
sir. Yes.
Yes, yeah, I understood. This what you are telling.
574.
Yeah,
Yes,
here
sir.
it's written is okay.
Load type
Yeah,
live.
got it. This, yeah,
Thank you, sir.
while defining, I didn't change the type. Okay, but I hope the syntax is correct now. Yes. Just a minute. Okay. Yeah, that's right. I will close the editor. And counter sharing version. Okay. Oh, let's hope it's fine and we do not have any issue with the file. Okay. So here we have defined most of the things. Let's check wind load. When I click on plus, I have this wind load. We have wind load on all 4 walls for all the cases like this. Okay. Just minimize it. Then we have these load combinations also. Next thing what we want to do is analyze. I'll just click on analysis, define command, perform analysis, add, close. Yeah, that's it. And then the next thing what is the design. Before designing it, let's analyze and see that we don't get any error. Here at
One
top
more thing
you
I
have
want to
this.
ask, because since we use this plate element for this floor modeling, is that not necessary to mesh it, or else what kind of load transmission we're expecting?
We have just modeled this slab load so that it can be considered in our dead load.
So how the beams
And
will be loaded?
beams, the load will be transferred from prime. We have applied these various dead loads and live loads. We have this earthquake and wind load. The load will be transferred from our secondary beams to primary beams and to the columns. And I don't think that the plate should act as a structural member in this case.
Because
He is
okay.
asking if you are assigning the plate, the nodal won't be the loaded portion. So the beams does not take any loads. If you are assigning the 4 nodal plate means then the node will be the load transfer as per the plate concern of in Staad Pro. So that is why he is asking.
So right now we have modeled that as a plate element.
Yeah, it should be meshed otherwise.
And if we don't mesh, the load will directly be transferred to our beams and columns.
It won't. Only the load transfer is only on the 4 nodes. That is
yes, but it's correct. But I'm not sure there is another option in a Staad Pro using this area load application. If we use this area load application, area load
then
application, not necessary to mesh it. Yeah.
Yes. Or
it will be directly transferred to this one. I'm not sure. That method is maybe.
We have 2 methods. If we apply by area load, then we know we don't have to mesh it. And if we are going with this plate, what we did right now, we need to mesh it. But right now I have not meshed it, and let's see. It could be that the load will be only transferred to the 4 nodes and not on whole beam. Okay, I am not sure of that. Let me check it and we will get back to that question. For now, we are not sure whether it will be 4 noded or the load will be transferred properly. But let's proceed with this.
Before concreting, वो layout करते हैं, उसका भी weight we have to consider for dead load.
Can you repeat the question?
There is before concreting, we have to put the CJ sheet.
Yes,
and the weight of the same to be considered in the.
Of course, there are many more things like you are saying. जब हम plate ये slab concreting कर रहे हैं, उसके पहले हम CJ sheets डालते हैं, तो उसका load भी हमें consider करना है.
करना चाहिए था.
Yes. There are many more kind of loads practically, like floor finish हमने discuss किया था पहले. Now you are saying one more kind of load. Okay, so let's analyze right now what we have done and hope we don't get any kind of errors.
Welcome you all in ISO certified live training program ETABS, RCDC and Excel that makes you a professional structural engineer. In this training program you will learn everything about ETABS and RCDC from basic to advanced, real life project of medium rise structure from architecture plan to final design sheet, real life project of high rise structure with all advanced topics, design of structural elements using advanced Excel sheets. Have a look over the features of this training. Daily live classes conducted by expert for 1.5 hours. Recording of every session with lifetime access. Can interact with expert anytime 24/7. Exposure to real practice. ISO certification of training completion. It's 5-star rated training program. Till now more than 1,000 participants have benefited from this training program. Now you are the next. Hello everyone, welcome you all in a new ISO certified live training program, design of substructure using CSI Safe, Excel and manual. In this training program you will learn all about the concept of substructure design, commands in CSI Safe software for the substructure design, validation of CSI Safe result with your manual and advanced Excel sheets. This training program will cover 4 real life projects. In the first and second we will cover all the types of isolated foundation in CSI Safe software. In the third real life project we will cover the raft foundation, and in the fourth real life project there will be the coverage of pile and pile cap design, design of basement wall, and at the end of this training program you will learn how to prepare the final design sheet for the site execution. Have a look over the features of this training. Daily live classes conducted by experts. Recording of every session. Can interact with expert anytime. Exposure to real practice. ISO certification of training. It's 5-star rated training program. Till now more than 1,000 participants have benefited from this training program. Now you are the next.
Yeah, till the analysis is complete, I want to ask one another questions. Usually in the steel building, so this is a composite floor decking systems now we are using for this concrete plate.
Yes.
So in that case, is there any options to model and design those composite floor deck panel in Staad Pro? Is there any options like that?
I think one of the option is like we should model the plate and then do the meshing of it so that that plate will also act as a structural member.
Because actually the questions I'm asking is because when you consider this primary and secondary beam, especially when we do the design point of view, so the ribs of this decks should be parallel to one directions and perpendicular to other directions. So this will
Yes,
affect this the lateral restraints, the torsional buckling restraints. So yeah.
Yeah, I understood. Yeah, and it could be, I think it could be modeled, and you need to mesh, you need to provide a plate element and then do proper meshing. But if you want to also model that shear legs which you have, I think that is not possible because that could be another critical thing.
Yes, exactly, sir. My question was the same. Like,
Because
if you only
the
check
shear
for
legs
dead
cannot be
load,
modeled.
yes, sir. Also, that the deflection would be quite less due to the composite action, sir. Right now, if you'll check, the deflection would be more.
Right. Let's check. Analysis is done and we don't have any error. Now I just want to show some design parameters what we have. Okay.
If there is an error, then how it will recovered?
If there is any error, then we should see what thing we have done and we should try to correct it. There could be any syntax error, or there could be something you have added and not applied. So that we will only understand after when we start doing it. Right? It's a trial and error method. Okay, let's discuss some of the basic design parameters which we should apply when we want to design now. Now the analysis is done. If we want to design this, there are certain design parameters. Of course, some of the basic parameters like the yield strength of steel, 250 ultimate strength of our material. If we have steel 415, we have to define FYLD, we have to define FU. Ratio, we want our members in particular utilization, then it should not be more than 1. Then we should define ratio command as 1. STP, if we are using our welded sections, then we have this value as 2 or 1, depending on type our section, whether it is a hot rolled section or no. Then we have track. If we want to get detailed output of the analysis and design, then we use this command track. We have options 1 and 2. I think we also have the option of 0, whether we don't want detailed answer, we want a summary, or we want everything in detail. These are the general things. Next is the KY factor, whether it depends on type of support, KY, KZ, LY, LZ, length of these members. Main, what we are going to apply today is this factor main, which tells us regarding the slenderness ratio. Like for example, my secondary beams, they are just for supporting transferring the loads. So in that case, I can have the ratio of this main as 200. Slenderness limit we can increase for certain members. Diff, this is for deflection. We want to define the joints DG1, DG2. This we are not going to use today. I just wanted to roughly tell you what we can have. Okay, so let's apply some of them in our model.
Sir, could you explain where we have to use KY, KZ, LX, LY, LZ?
Okay,
Actually, I'm not able to understand where to KY and KZ we have to take 1.75 like that. So please elaborate a little bit.
It depends on type of our support. If we have both pin supports, and for that column, if we want to give this factor, then the K value is 1. If you have both fixed support, then this value of K is 0.65. But your question is where you should use KY and where you should use KZ. For example, if you
in member.
in member, yeah. For example, if you have this member, and if if you have this member somewhere in middle, and if it is able to deflect in one direction, then in that direction you have to consider it as simply support. And if in the other direction you have wall or you have bracing, then in that direction the length will be different. Maybe in this case you won't be able to understand that properly, but if you have designed any steel warehouse and PEB structure, in that case it is much clear. Okay, so now, because as we are really short of time, I would just like to go with the design thing I have chosen. If you click on design over here, you have the option over here to choose your code. We are going with IS 875 2007 limit state method LSD. And if you click on define parameters, here are many parameters. We have discussed some of them which you can apply. Right now, let's apply FU 420000. I'm just adding it right now. FY 250. Main 250 in case of my secondary beams, because ratio 1 STP hot rolled section, say add. Okay, so these are the few things we will just add so that it's
सर
easier for us
बेसिकल
to design.
स्लटर रेशियो 350 तक जा सकता है ना सर?
हाँ, जा सकता है 350 फॉर द डायगोनल ब्रेसिंग्स 350 तक जा सकता है. ओके, सो बेटर इज
LZ ऐड नहीं करेंगे?
नहीं, अभी के लिए हम ऐड नहीं करेंगे बिकॉज दैट विल रिक्वायर मच मोर टाइम. अभी के लिए वी आर जस्ट कंसिडरिंग व्हाट स्टैट
सर
जनरेटर
कर
टेक्स.
सकते हैं ना सर इसमें भी
या
ऐड?
करना है, वो तो करना है डिपेंडिंग ऑन योर टाइप ऑफ सपोर्ट्स.
ओके सर.
But as regarding the design parameters, it was just introduction to design parameters, so we are just roughly adding a few of them.
ओके सर.
Okay, so FU I'm adding assign to view, assign yes. FY again assign to view. Main, for main we will give this to only our bracings and secondary beams. So select group SB and bracing. So we have given up to 350. Assign to selected beam, yes. Ratio we will give for all. Assign to view, yes. STP, all are my hot rolled sections. Assign to view, yes. Okay, so these are just a few of them. We should of course add more. And command, of course, now we will check it with this code. Go down, check code, assign to view, assign yes. Okay, so let's go in analysis and design, run analysis, save.
आनंद कटवर्क नहीं स्टील कटवर्क नहीं
Could you please explain this application of these important parameters like kx, ky, and lx, ly, and dj1, dj2? I think these 6 parameters are very important when we are doing this steel building design now.
Yes, sir.
Yeah, of course, while designing these steel buildings, those are some of the important parameters. But of course, we do not have time now to detail understand all of them in detail. But roughly, I would just like to explain.
Yes,
K,
yes, yeah, rough
yeah,
idea about how to.
KY, KZ. See, if you have your, in my case, now I have at the bottom a pin connection, and at the top I have my fixed connection. So in this case, the value as per our code, it is given as 0.8. So this is the factor of K, which is 0.8. But now we should understand KY and KZ, where we want to use this value. So if my member in the other directions, I have these bracings. So for Ly, where we have these bracings, we can break the member. But in my case, for both the directions, now the Ly, Lz will be 3.3. That is height of my structure. And Ky, Kz, it will be 0.8 because one is simply support and other is fixed. So based on my support conditions and depending on my height, those values generally change. And if I have my warehouse where along one direction I have my wall, but along other direction my column is free to bend. So in that case, Ly will be different for y direction, and means x direction Ly will be different because in that direction I have my wall. So depending on the height of my wall, the length of my member will change. But in the other direction Lz, which I do not have any wall, that I will have complete height of my column. For example, it could be 5 meters or 4.5 meters. So this depends on the
For
type
example,
of my
if we take
structure.
this main beam, actually the main beam is supported by, I think, 3 or 4 secondary beams. So in that case, so we have divided in the main beam
Yeah,
into 4 or 5
this,
segments. In
yeah.
that
So in
case,
that case,
LX,
in that case, problem will be regarding deflection. So
yeah,
I have to define this first point and the last point as dj1 and dj2. So when it is calculating the deflection, it won't consider them as separate members, it will consider them as one member. So because of my secondary beam, my primary beam is also broken into many pieces, but I don't want that for my deflection calculation. So I have to use dj1, dj2, starting of my member and ending of my member. And diff is my deflection limit. Kx, Ky, Lx, Ly, generally that we use when we want to calculate the compression of our columns, the buckling of our columns. That is generally used for our columns. Okay, let's see. We have 0 warnings. Okay, 0 errors. We have certain warnings. Uh, Now let's see if any of our members are failing. If you go in select property name, you can directly check if what are our failing members. So these are some of the members which are failing. So you need to either increase them or check them why this is the case. And when you want to in detail understand, here we have the option of post processing. Click on post processing, say okay. Here you will get deflection of all your members, the utilization ratios. If you want to see the reactions of your supports, when you click on reactions, you have all these reactions. And for the maximum reaction, then you can model your footings, beam results. If you want to see each and every results in detail, this is the tab where you get the results. What is important for us is from here, if you want to define your connections, if you want to under design your connections, then you need to take certain forces from here. uh, Select all secondary beams, New view, okay. Now if we want to check the forces of these members to design our shear connections, I would also like to show you one Excel. It's a Excel for connections. For example, column beam connection. If you want to design your column beam connection, you just have to choose your primary beam and calculate the maximum force which you are getting in your primary beam from these tables. Okay, and you just have to paste your values over here. You have to add your lever arms. You have to define your section, whether it is right now this is for tapered, but if you have your I sections, you have to define your I sections and try to understand how many bolts you need. This is
Can you share this Excel sheet, sir?
yeah, this Excel sheets will be shared with you. Here you will get all the shear capacity, bearing capacity, tension capacity, and number of bolts which you require.
Is
Your
there
connection.
any inbuilt this add-ons in Connect editions to export these results, and we can do the connection design using the stat itself?
Yeah, in Staad we can do the connection design. In that we have the RAM software of Staad, which is used for connection design. That's called RAM. In that you can directly, means it's also the software of Bentley, where you can directly take these results from this and you can model your connections in RAM software. But the software is really complicated, and we have a simpler software called as Idea Statica. Most of the industries try to use that software. It's a little bit user friendly, and you can export your results from your Staad, and then you can use the Idea Statica software to design your connections.
Okay.
सर मेरा एक
And
क्वेश्चन था इसमें
yes.
सर जो हमने प्लेट एलिमेंट लिया है अभी हमने देखा है जो यूटिलाइजेशन रेशियो है हमारा वो काफी कम है लेकिन अगर मैं मान लीजिए इसी को चेंज करके फ्लोर लोड ले लेता हूँ
yes.
तो क्या ये जो यूटिलाइजेशन
ये
रेशियो है वो चेंज होगा या नहीं होगा?
वो होगा, बिकॉज या अभी हमने इसमें एक मिस्टेक ये किया है कि हमने उसको प्लेट लोड एज अ मॉडल किया है. तो फर्स्ट ऑफ ऑल उसको हम एज अ एरिया लोड करेंगे, देन इट विल ओनली ट्रांसफर द एरिया. हमें प्लेट लोड मॉडल नहीं करना चाहिए था. दैट वाज वन ऑफ द रीजन व्हाई दिस मॉडल इज नॉट एक्यूरेट नाउ, बिकॉज अभी वो कंसिडर कर रहा है कि प्लेट प्लेट हमारा स्लैब भी कुछ लोड ले रहा है, उसके ऊपर से हमने उसको मैशिंग भी नहीं दिया है. सो वो अभी बाय डिफॉल्ट जो मैश आता है
नहीं
उसके बेसिस पे कैलकुलेशन किया होगा.
अभी कंडीशन ये है कि जो हमारी प्लेट है वो एज ए मेंबर एक्ट कर रही है.
हाँ, तो हमें वो नहीं चाहिए, तो वी शुड गिव एरिया लोड. वो एक मिस्टेक हो गया है कि हमने इसमें प्लेट लोड दिया है. तो अगर हम इसमें एरिया लोड देंगे तो इसका एफिशिएंसी चेंज हो जाएगा, एंड इन दैट केस might be some of more members will fail, and accordingly we should change them.
दूसरा कंडीशन सर एक और सवाल था मेरा कि मान लीजिए अभी जो मेरी हाइट है वो 15 मीटर के अप्रोक्स है बिल्डिंग का और
yes.
जो मैंने अपना जो कंडीशन रखा है मैंने सपोर्ट का वो पिन रखा है.
हाँ.
ठीक है जी. तो जो सिस्मिक जब मेरा सिस्मिक स्टार्ट होगा ठीक है जी तो उस टाइम पे जो मेरा डेल्टा होगा बिल्डिंग का क्या वो ट्रांसफर होगा या नहीं होगा?
नहीं, अभी के लिए हमने सिस्मिक में इसमें क्या किया है, जो बाय डिफॉल्ट टाइम पीरियड आ रहा है 0.5 का, वी हैव डन बाय दैट. अगर सिस्मिक के लिए इन डिटेल कैलकुलेशन करना है तो हमें टाइम
नहीं, अभी
पीरियड
तो हमने
भी निकालना
कैलकुलेशन किया
पड़ता
ही
है.
नहीं ना सर. एक्चुअली
हाँ,
जो स्टैड में है अभी कैलकुलेशन हमने किया ही नहीं है.
हमने बाय डिफॉल्ट जो इसमें आ रहा है वो ले लिया है. इसमें क्या होता है,
सर ये जो हमारी ये मीटिंग है वेबिनार है ये एक ओवरव्यू है.
यस.
इसमें हम फाउंडेशन देयर आफ्टर सुपरस्ट्रक्चर एंड ट्रस, उसके बाद में उसका डिटेलिंग, एक्सेल शीट इन डेप्थ में, उसके बाद में आपका जो
सब हम
फैब्रिकेशन है
आगे
ये
डिस्कस कर
कंप्लीट
सकते
करने
हैं।
के लिए सर
कंप्लीट करने के
डिटेल
लिए
होना चाहिए इसमें,
yes,
ताकि
of
जैसे 1
course.
महीना 1.5 महीने की ट्रेनिंग हो तब वी कैन गेट
राइट, दिस इज जस्ट एन ओवरव्यू। हम जस्ट एक
हाँ
3 घंटे में हम क्या ही कर सकते हैं, एक बस
हाँ
ओवरव्यू
नहीं
देखते हैं।
3 घंटे में कुछ नहीं होना सर। इसमें अगर आप कुछ ऐसा प्लान करें ताकि 2-3 महीने के हो, बंदा इन डेप्थ में जाए, तो तब उसके लिए सब कोई अरेंज किया जाए तो ज्यादा बेटर रहेगा।
Yes, sir, you can say.
Yeah, actually keep this question answer session for the end. Okay. So, request with you all guys, please keep your question answer in the chat box. So the Nishan sir will answer to your question at the end. Okay.
Okay, so this is what we did now. Abhi just going back to our presentation.
Welcome you all in ISO certified live training program, ETABS, RCDC and Excel that makes you a professional structural engineer. In this training program, you will learn everything about ETABS and RCDC from basic to advanced. Real life project of medium rise structure from architecture plan to final design sheet. Real life project of high rise structure with all advanced topics. Design of structural elements using advanced Excel sheets. Have a look over the features of this training. Daily live classes conducted by expert for 1.5 hours. Recording of every session with lifetime access. Can interact with expert anytime, 24/7. Exposure to real practice. ISO certification of training completion. It's 5-star rated training program. Till now more than 1,000 participants have benefited from this training program. Now you are the next. Hello everyone, welcome you all in a new ISO certified live training program, design of substructure using CSI safe Excel and manual. In this training program you will learn all about the concept of substructure design, commands in CSI safe software for the substructure design, validation of CSI safe result with your manual and advanced Excel sheets. This training program will cover 4 real life projects. In the first and second we will cover all the types of isolated foundation in CSI safe software. In the third real life project we will cover the raft foundation, and in the fourth real life project there will be the coverage of pile and pile cap design of basement wall, and at the end of this training program you will learn how to prepare the final design sheet for the site execution. Have a look over the features of this training. Daily live classes conducted by experts. Recording of every session. Can interact with expert anytime. Exposure to real practice. ISO certification of training. It's 5-star rated training program. Till now more than 1,000 participants have benefited from this training program. Now you are the next.